Welcome to Master Chem Academy. So today we are going to discuss about this Knovenegel reaction. Okay, important name reaction from carbonyl compounds. Okay, what is that? Knovenegel reaction. What is that? Aldehydes are ketones. Aldehydes are ketones with no alpha hydrogen atom. This is the condition. What is the condition? No alpha hydrogen atom. Aldehydes are ketones with active methylene compound. Active methylene compound in presence of weak base. In presence of weak base. So this reaction is known as gives corresponding product. Corresponding product. Okay. So this reaction is known as Knovenegel reaction. What is that? Condensation of aldehydes or ketones with no alpha hydrogen atom with active methylene compound in presence of weak base is called Knovenegel reaction. Okay, let us take one example. So that is, familiar example with no alpha hydrogen atom is benzaldehyde. Okay, so this is benzaldehyde. So no alpha hydrogen. So aldehyde or ketone with no alpha hydrogen with active methylene compound. What is active methylene compound? Whenever CH2 is attached to withdrawing groups, that is said to be active methylene compound. Okay. Now CH2COOH, COOH. This is 2 are electron withdrawing groups, COOH, COOH. That's why. So this is active methylene compound. So this is malonic acid. Malonic acid. In presence of weak base. So this base may be Et3N or pyridine or piperidine. Okay, so in presence of this, so this give what is the product. Okay, so how to write this product? First this converts into C double bond O group, this converts into CHOH, and there is a bond will be formed between this carbon and active carbon, active methylene carbon. So that is CH, COOH. Okay, this is the compound by this reaction. So immediately, so whenever hydrogen OH on adjacent carbons, dehydration takes place, minus H2O. So that leads to the formation of CH double bond CH, COOH. Okay, now this on heating, decarboxylation takes place. Okay, heating to 150 to 200 degrees centigrade. Okay, so decarboxylation, minus CO2 takes place, and what it gives? So that gives the given compound is CH. Okay, C double bond C, C double bond C. Here it is benzene ring. Okay. Now hydrogen and COOH. Trans-cinnamic acid is the compound. What is the Knovenegel product? Okay, trans-cinnamic acid. We know that CH5 CH double bond CH COOH is cinnamic acid. So transposition, the groups are present in transposition. That's why trans-cinnamic acid is produced by Knovenegel reaction. So once again, what is the reaction? Benzaldehyde with malonic acid in presence of weak bases. So first it produces this product by dehydration. Hydrogen from here, from OH from here removed as H2O. So that's why a double bond is arised because of this loss of H2O. Okay, hydrogen from here and OH. So loss takes place in this manner, HOH. That's why So a double bond arises in between these two carbons, and now here it is dicarboxylic acid. By heating to 150 200 degrees centigrade, CO2, loss of CO2 takes place, and what is the resultant product? So due to this loss of CO2, so now at this carbon CH2 is there. Okay, CH 1 2 3 4 already here there is no CH, already hydrogen is eliminated, there is no CH here. So by the loss of CO2, so it is having only one CH and COOH, CH COOH. Okay, this is Knovenegel reaction. This is example 1. So if you take example 2, so I am replacing this hydrogen with ethyl groups. Ethyl groups. What is this? Diethyl malanoate. Diethyl malanoate, because malonic acid, 2 hydrogens are replaced with 2 ethyl groups. Okay, this is example 2. So diethyl malanoate in presence of weak base. So what is the product? Same CHOH, but here hydrogen. So COOET. COOET. Okay. So to get this product, from this, so first one more step is required here. So first of all dehydration required. So ET. Okay. By the dehydration, in the same manner dehydration takes place. So double bond is arised. So now this one. Okay. So here first we should convert COOET to COOH. Okay. That's why one more step is required here. So that is from this here hydrolysis. By hydrolysis we can convert ester into acid. Okay. So what is the compound? What it gives? C6H5, CH double bond C, COOH, COOH. Okay. COOET is converting now as COOH. How it is? Hydrolysis takes place in this manner. HOH. Okay, 2 moles of water required. So COOH. Remaining side products are ethyl alcohol, 2 moles. Okay. Now, so previous example compound now again regenerated here. Here this by heating minus CO2 150 to 200 degrees centigrade heating. So again cinnamic acid is the product. Okay. So what is the product? Cinnamic acid. C6H5, so benzene ring, and CH double bond C, COOH, H. So this is cis-cinnamic acid, but it is trans-cinnamic acid. That's why I should write like this. Okay, trans-cinnamic acid is formed by Knovenegel reaction. So example 1 with the 2 examples I have explained this Knovenegel reaction. So what you should remember, aldehyde or ketone, any aldehyde or ketone with no alpha hydrogen atom. So not only aldehyde, it may be ketone also. C double bond O C6H5, C double bond O C6H5. Okay, here there is no alpha hydrogen. Okay, aldehyde or ketone and active methylene compound. Not only these 2 examples, any active methylene. So how can you define active methylene compound? So in between CH2 group is in between 2 withdrawing groups. These 2 withdrawing groups may be any one, CHO, COOH or COOH, COR or C double bond OR or this between CN, all these are withdrawing groups, or CN NO2. Okay, so all these are electron withdrawing groups. So whenever CH2 is attached to electron withdrawing groups, that is called active methylene compound. Any compound we can take here. And a weak base, so ET3N, pyridine or OR minus or CH3COO minus, ET3N or pyridine or piperidine. Okay, so piperidine. So any of this act as base, weak base. Okay, so in presence of weak base, so Now, so 3 components. We know that aldehyde are ketone with no alpha hydrogen. Now we are familiar with the active methylene compound also, and also examples for weak bases for used in Knovenegel reaction. Okay, this is the end of Knovenegel reaction. Thank you.